Hello, chemistry students. I am absent today, but we're going to go ahead with the lesson. So if you could get out your Chapter 10, Section 2 notes, we're going to go through some notes. I'm going to do a sample problem, then ask you to stop the recording, try a couple of the problems, and then check your answers with what I do here online. So in Section 2, in Section 1, we talked about the mole and how many particles. In Section 2, we're going to relate the mass of the mole to we're going to relate a mole to its mass. The big idea is a mole always contains the same number of particles. However, moles of different substances have different masses. So let's look back to the dozen. Just for a warm-up here, if we have a dozen roses, a dozen donuts, or a dozen cars, we have 12 of each, but they're not all the same mass. A dozen donuts might be 2 pounds, a dozen roses 4 pounds, a dozen cars might be 12 tons. So even though they're all a dozen, they have different masses. Now let's look at the same idea with atoms. Say we have hydrogen atoms and lead atoms. If we have a mole of hydrogen atoms, we know we have 6.02 times 10 to the 23rd atoms. If we have a mole of lead atoms, we have 6.02 times 10 to the 23rd. But let's look at the difference here. We have hydrogen with 1 proton, and we have lead with 82 protons. So which one's going to have more mass? Of course, the lead, which has more protons and more neutrons than the hydrogen. Same number of each in each mole, but the lead is definitely going to have more mass. Now we need to define a term, and we're going to call it molar mass. Molar mass is simply the mass in grams of 1 mole of any pure substance. It is equal numerically to its atomic mass on the periodic table, and it has the units G/mol, which means grams per mole. So let's look on the periodic table. If we have a mole of hydrogen, we have 1.008 grams of hydrogen. If we have a mole of oxygen, we look at the atomic mass, and we would have 15.999 grams of oxygen. A mole of cobalt would be 58.993 grams. A mole of potassium would be 39.098 grams. So a mole of any element is equal to the atomic mass, although you make the units in grams. Now, let's learn how to convert moles to mass. To convert moles to mass, we're going to multiply moles by the molar mass. So let's look at our first example here. What is the mass of 0.0450 moles of chromium? Well, I start with what I have, 0.0450 moles, and now I use my conversion. And in this case, my conversion is I know 1 mole is equivalent to the molar mass of that substance as given on the periodic table. So I look on my periodic table, I look for chromium, I see the mass is 51.996, so 1 mole is 51.996 grams. I want my answer to be in grams, I want moles to cancel, so I set up my problem this way. It tells me I need to multiply moles times grams. 0.0450 times 51.996 is 2.34 grams. So 0.0450 moles of chromium is 2.34 grams of chromium. Now, I want you to stop the tape, try the next 2 problems. You're going to start with what is the mass of 4.89 moles of gold. Try that in the next problem, and then start the tape and we'll go over those 2 problems. Okay, let's look. What is 4.89 moles of gold? 4.89 moles, I have to look up gold on my periodic table. Gold is 196.967 grams. So I write that up here. I know that's per 1 mole of gold. So I'm going to take the number of moles times the mass of each one, 4.89 times 196.967, and get 936 grams. Same thing for lead. 0.0021 moles of lead. I want to know how much mass that is. I know for lead, 1 mole is 207.2 grams. So here's lead, 207.2 grams. 0.0021 times 207.2 is 0.35 grams. All right, next, what if we're going mass to moles? What if we want to convert mass to the number of moles we have? We just do the reverse. We take the number of grams given of any substance. We use our same conversion, mole and molar mass, only we're going to put 1 mole on top and molar mass down below because we want the grams to cancel. So this tells us we need to divide, and that gives us the number of moles. So first example, how many moles are 31.1 grams of gold? I have 31.1 grams of gold. I want to convert it to moles. I know that 1 mole is 196.967 grams of gold. You see that from the periodic table. And so I take 31.1, I divide it by the 196.967, and I get 0.158 moles of gold. Now, stop this recording. You guys try the next couple of problems, and then turn it back on and come and check your answers. Okay, sulfur. I have 300 grams of sulfur. How many moles is that? 300 grams. I know if I look up sulfur on the periodic table, I have 32.066. 32.066 grams is in 1 mole. I take 300 divided by 32.066, and I get 9.356 moles of sulfur. How many moles are in 630 grams of calcium? I have 630 grams. I look up calcium. It has a molar mass of 40.078. So I take 630 divided by 40.078. I've got 15.7 moles. All right, here's another couple of questions. Turn off the tape and try the next couple of questions. See what you can do with them. And then turn back on the recording and we'll go over the answers. Okay, mass to atoms. In this case, we have a mass, and we want to find out how many atoms is in that mass. Not moles, but atoms. There's no direct conversion from mass to atoms and atoms to mass. You're going to have to do a double conversion. You're going to have to go to moles first. So the first thing I do is I take my 11.5 grams of silver, and I'm going to convert to moles. So I look up silver on the periodic table. I see it's 107.868. So I know 107.868 grams per mole. I put grams below because I want grams to cancel. I want to be left with moles. 11.5 divided by 107.868 gives me 0.107 moles of silver. Now I can convert moles to how many atoms are in that silver. So I know I have 0.107 moles. I know there's 6.02 times 10 to the 23rd atoms per mole. I put atoms on top and moles down below because I want the moles to cancel. That tells me to multiply these two numbers, which gives me 0.644 times 10 to the 23rd, which is 6.44 times 10 to the 22nd atoms of silver. Now let's try another one, atoms to mass. Let's say we know how many atoms we have, and we want to calculate its mass. Again, there's no direct conversion from atoms to mass, and we're going to have to do a double conversion. And I did this one a different way so you can see both examples. In this first example with the Kennedy half dollar, I changed grams to moles, and then I did another conversion, moles to atoms. This time I'm going to do it all in one step, and so now maybe you can see why I write these things out as fractions and conversion units instead of just writing them as a division or a multiplication problem. This problem states, what is the mass in grams of 5.50 times 10 to the 22nd atoms of helium? I have atoms. I want to find mass. Well, I can't go straight to mass, but I know that 1 mole is 6.02 times 10 to the 23rd atoms. So by multiplying by this conversion factor, I can calculate how many moles. I put atoms below because I want atoms to cancel, and then I'll be left with moles. However, I also then want to take these moles and I want to convert them to grams. And rather than doing it in 2 steps, I can just add my second conversion factor right here. I want my answer to be in grams because they're asking for grams. So I'm going to set up my conversion factor to have moles in the denominator, so moles cancels, and grams in the numerator. And I'm working with helium. So helium has a mass of 4.003. I put 4.003 grams on top. And now use your units to check yourself to make sure you're multiplying or dividing correctly. I make sure atoms cancels. I make sure moles cancel, 1 in the numerator, 1 in the denominator, and I'm left with grams. Now I simply have to multiply 5.5 times 4.003 divided by 6.02, and I get 3.66. 10 to the 22nd divided by 10 to the 23rd is 10 to the negative first. Or you could have written this as 0.366. So there's 2 different ways to do this problem, and you may do it either way. You can do the double conversion, or you can do it all at once. I would recommend, if you're somebody that's looking to go into physics, that you could get familiar with this method, the second one we did, because that's they call this dimensional analysis, and that's the way you're going to do your calculations in physics class. All right, that's it for today's lesson. I did make a module on ALEKS for you that has to do with moles. It only has 2 topics, so if you do use the rest of your class time to work on those topics and try those problems that have to do with the number of particles in a mole and molar mass, that will help you with your minutes this week and will help you with your practice with moles. Tomorrow we'll do more practice problems on these for the short class period that we have, and we're going to have a quiz over all of this on Friday. See you guys tomorrow. Bye.